all talking during the test. You have 1 hour to complete it. You may begin.
How much do you weigh?
Mass.
How fast are you going?
Velocity.
Do you like to wear spandex?
Elastic.
Momentum!
You take an object with mass and give it velocity.
Keep talking, whoa, keep talking.
Then you get momentum where P is equal to mv.
I love equations, oh, I love equations.
Another thing to know is momentum is conserved
In every situation, even in a car collision. Momentum, go, 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 go.
F equals ma and impulse is F.
Momentum is the quantity of a motion of a moving object, and it is expressed in the equation P equals mv. And basically, mass and velocity is what determines the momentum of an object. So first, P stands for momentum and is expressed in the units kilograms times meters over seconds. And then P equals mv, right? So m is the mass and expressed in the units kilograms. And then there's v, which is velocity and is expressed in meters over seconds. For an example of momentum, here is an amazing dinosaur walking in the hallways. With the dinosaur walking, the way you would calculate its momentum is to multiply its mass by its velocity. So therefore, you would multiply 0.75 meters per second times its mass, which is 50 kilograms, and you would get 37.5 kilograms times meters per second. Due to sig figs, we would have to round it to 38 kilograms times meters per second. The law of conservation of momentum states that the momentum of objects in a close isolated system is conserved, meaning it does not change. Therefore, the total momentum before equals the total momentum after.
Suppose we have a stationary cannon. Its momentum is 0, but when we fire a cannonball, the cannonball is given a momentum in the forward direction. The cannon is also given a momentum just in the backwards direction, resulting in it rolling backwards. The momentum going forward and the momentum of the cannon going backwards are the same, but they're in opposite directions, which means the net momentum is 0, making it consistent with the law of conservation of momentum. Impulse is a different kind of momentum. It's directly proportional to the force applied to an object. You can determine it using the formula delta P equals F times delta T. And the units for it are newtons times seconds. Notice how this unit is equivalent to kilograms times meters per second. But for impulse, we're going to use newtons times seconds. Impulse is especially used when dealing with time and force, giving us the amount of force applied over how much time. Hence the impulse on an object.
To wear spandex?
Here is an example of impulse. A man kicks a soccer ball with a force of 200 newtons for 0.05 seconds. To calculate the impulse applied, we will use the formula delta P equals F times delta T. The 200 newtons would be the force and the 0.05 seconds would be the time, giving us an impulse of 10 newtons times second with 1 sig fig.
In every situation,
There are two types of collisions. The first one is called elastic collision. It's when two objects collide and then they go off separately. And then the second type is called inelastic collision, when two objects collide and then they stick together. For elastic collision, the total momentum before collision equals the total momentum after collision.
Here's an example of an elastic collision. A small tire collides with a big tire, and they bounce off each other and go opposite ways. To calculate the velocity of a bigger tire, we will use the formula for elastic collision. By plugging in numbers into the formula, we can work out the velocity of the bigger tire after. Notice how the initial momentum of the small tire is equivalent to the afterwards momentum of the big tire. This is because the momentum was all given to the big tire, and it still follows the law of conservation of momentum.
So this is the formula for inelastic collision.
Suppose we have a freight train car moving at 10 meters per second and it runs into another identical one that's stationary. If they collide, stick together, and they keep moving forward, what would their velocity be? To calculate this, we would use the equation for inelastic collision. And even if we don't know the mass of the carts, when we look at the equation, we can see that the mass of the combined carts is twice the mass of an individual cart. That's because they're the same cart and they have the same mass. If the mass was 2 times the value it was before, because momentum is conserved and does not change, the velocity would be half its value before, which is 10 divided by 2, which is 5.
Momentum is the... I'm a behind camera person. Okay, momentum is... Oh! And is expressed in the units...
Keep going. Ready? Go.
Impulse is a different kind of momentum. It's blah blah blah.